In this segment for week 1, assignment 1, we're discussing number 14 for Cosmo, the hair shaft. This is very super important because if you don't understand how the structure of the hair is, how will you know which chemical to use, how strong, how long, and what the effect will be? Some hairdressers are just lucky. They're good guessers. They have a natural instinct. But once again, when you have the science behind why things work, it gives you a better chance of doing things correctly, especially as a newbie. When you're first starting out and you don't have very much experience, it's kind of difficult to know what to choose to use on who to get the result that you want. So we're going to start with the hair shaft, and there's 3 basic layers to the hair shaft: the cuticle, cortex, and medulla. The cuticle layer is going to be referred to as your outermost layer, and the medulla is going to be referred to as the innermost layer. The state board isn't going to say layers 1, 2, 3, because some teachers will teach the inner is 1 coming out this way, and especially when we get into skin structure, okay, going either direction, they're going to say outermost and innermost. And interestingly enough, the word cuticle refers to the outer layer of hair. But remember, it's also the skin around your nail. And it's also the outer layer of your skin. So if the state board asks you, the term cuticle refers to, and A says hair, as a hairdresser, you're liable not to read B, C, D is going to be all of these. Okay, so if you were a manicurist, the cuticle around the nail would be first. And if you're an esthetician, A would be the outer layer of skin, and then we wouldn't read B, C, and D. So it's really important that you read all of the answers, then go back and reread the question so that you know what they're asking you. The chances are you know the answer, you're just not paying close enough attention to the actual question and what it is. We're going to start with the cuticle layer, because it's the outermost layer, and its job is to protect the inner 2 layers. Just like the cuticle layer of the skin is there to protect all of the other layers underneath it, the cuticle of the hair shaft is the same thing, and it's referred to as porosity. Okay, and porosity has degrees. There's hair that's very resistant. The cuticle layer is very tight and closed, like it's supposed to be. Then you have the normal wear and tear, like from blow dryers and curling irons and such, and the cuticle is a little more porous. Then you have chemically treated hair, where the cuticle has kind of been trashed. Okay, and so the protection job is no longer there. So when I'm talking about my innermost layer, having my moisture content, I can have dry, brittle hair. So I need to make sure that when I'm working with my chemicals, I try to go back and seal that cuticle over again, okay, and make sure that I'm giving the client all the protection they need. The cuticle layer is composed of overlapping scales, and their technical name is imbrications. That's the actual name. They're not, I mean, the book says, like, you know, the scales of a fish or the shingles on your roof. That's an example, but they're literally called imbrications, and they overlap with each other. So when I'm looking at my overlap, okay, they can be up to 11 layers thick for super resistant hair. Normal is 5 to 7. Or I can have thinner hair. Now, I'm not talking fine. I'm talking about hair that's not as healthy on the outside, and it could only have maybe 4 or 5 layers of cuticle. So I don't have near the protection, and you don't know what that is. Okay? There's no way without a microscope that you can go in and look at the cuticle layer and know how many layers they have or the condition they're in. We have this as an educated guess. There are tests for porosity, which we'll talk about in other classes, and how hair is resistant. A lot of times your client will give you the first clue. My hair won't do this. My hair doesn't do that. I can't get it to do this. And there's any number of reasons for that. But most importantly is its hydrogen bonds. The book just refers to them as H bonds. Okay? but hydrogen is positively charged. The more imbrications I have, the more positive ions I have. The second layer is composed of sulfur. Remember, sulfur is negative. Every sulfur atom is a negative 2. Okay? So for every one you see 2 negative ions. Hydrogen is a +1. You have twice as many hydrogen bonds as you do sulfur bonds. The hydrogen bonds are what are affected in thermal or physical changes. Okay? So how much heat? How long of heat? What is the proper, how much heat do I need? You know, especially if you're pressing curling and you're in a stove. There's no way for you to monitor how heat. I mean, 100 years ago, no, we still do it. Joking. Hairdressers ran the comb under their nose to see how hot it was. And if I couldn't get this close, then it was too hot. And then we'd cool it down. Okay? Don't do that at the state board. Not a good idea. Okay, well, probably not a professional idea anyway, but it works. Okay, so protection and thermal work, my flat irons, okay, and my ionic tools, okay, wet hair, water, H2O, positive and negative ions. A negative ionic blow dryer. Those negative ions coming out of the blow dryer attach to the positive ions in the water, and they break the molecule apart, reducing your drying time in half. If I'm using a flat iron, okay, the cuticle is positively charged. If my flat iron is negative, well, let's go back. Positive ions repel each other. So when I brush my hair, it flies all over the place. Okay? When I blow dry it, it gets bigger and bigger and bigger. I should be so lucky. It doesn't get bigger and bigger on fine hair, but there are some of you out there who have a whole lot of hair, okay, and you want it close to the head. So you use a negative flat iron because it neutralizes the positive ions of the cuticle and the hair lays flat and close to the head. Don't do that to me. The little old ladies like their poof. You take away that static electricity from fine hair, and fine hair doesn't look nice when it's flat and close to the head. We need that. So it's not the tool that's going to give you that you didn't know how to use it or why you're going to use it and then how to use it. So that's super important. It has to do with the cuticle layer because that's my physical change. When we step into the cortex, this is where chemical changes take place. Now, the chemicals, depending on which one it is, and we'll discuss each one individually, but we're always going to be coming back to this hair structure, which is why I want it diagrammed, and I want you to understand explicitly that I have cross bonds going across my polypeptide chains. Polypeptide chains are chains of amino acid proteins that kind of resemble Link sausage. Remember Oliver and Company, a little doggy with a little Link sausage wrapped around his neck. Okay, so it's the Link sausage. And each one of these chains is held together by a bond that's on the end. The end bond is an S bond. The cross bond that binds them together is also an S bond. Okay, so if the book says it affects the S bonds, which one are they talking about? Yeah, that's kind of for you to know. And you have to figure that out. So we're going to discuss that today. But my end bond has a technical name. It's called cysteine. C-Y-S-T-E-I-N-E. It's on the end because of its physical location. Okay, end begins with an E. Cysteine has an E in it, and it gives my hair its elasticity, the ability to stretch and return, because it is the soft form of sulfur. Now, when we're talking about the elements, and you have water, water is available in 3 forms. It's the only element that comes that way. Water is available as a liquid, drinking, as a gas, when you're cooking and the steam comes off of your pots and pans, as a solid, ice, and as a semi-solid, snow. But I still have H2O. It has not changed its identity. So when we're talking about our sulfur bonds and our end bonds, we're talking about the soft form of sulfur kind of like snow, I can reshape it. When I'm talking about cystine, I'm talking about the hard form. These are the ones that go across. So by virtue of their location, they're referred to as cross bonds. Okay? And this is the hard form of sulfur. It gives my hair its strength. Very important for you to know. Now, another thing you cannot tell by observation is how close together they are. So if my cross bonds are very, very close together, I have an extremely strong hair shaft. If they're spaced at a, quote, normal spacing, then I have normal hair. But if they're extremely far apart, my hair shaft is weak. Now, what controls that? My diet, my health, medications, and other things that go on that have to do when the hair is still in the growing stage beneath my scalp, with the papilla and how much water I'm drinking, how much, if I'm having good vitamins. But sometimes, you know, as women, we decide we want to lose 5 pounds, we won't eat this week. Okay, so that week my hair isn't going to have any nutrients. Okay, so it's going to fluctuate more with women than men. Okay, because we cycle, and as we cycle, our body chemistry changes. So we want a diet that's high in sulfur, okay, so that we give our body enough. Remember, cones, C-O-H-N-S, carbon, oxygen, hydrogen, nitrogen, sulfur. Okay, so I need a diet that's higher in sulfur so that my body has the elements it needs to give me a good, healthy hair. Once again, you can't visually see this. So a client is going to give you some clues. I get a lot of breakage. My hair won't curl. I can't do this. It won't do this. It's too much this. It's too much that. It won't hold a curl. And so this is all in your spacing and the strength, the inner structure of the hair shaft. So for every sulfur atom, I have 2 negative ions. For every hydrogen, sulfur, I have 2 hydrogens. Because my positives and my negatives, that's what holds the hair shaft together. Then if you notice, the medulla is called pith, and it's referred to as, you know, the soft layer. It's like soft keratin. That's where my hair gets its moisture. So if I have damaged my cuticle and my moisture can evaporate, my hair isn't going to look very pretty or be very healthy. So I have to make sure when I'm altering this, I seal this so my medulla keeps the hair moisture that I need. Now, what chemical does what damage? Or restructuring, I shouldn't say damage, I should say structure. Because wedged in here through all of this other stuff are my pigment granules, okay? Which is completely discussed in hair coloring. But inside of all this, wedged in here, are pigment granules, okay? So when I'm working on the hair, I have to know what chemical did the structure damage so I know what conditioner to use. One conditioner is not a one size fits all. A house that has a fire versus a house that has a flood does not have the same structure damage. The fire eats away at the beams and it weakens them. Where a flood just causes everything to expand, you could have mold, but you don't have the weakening of the structure that you have with other chemicals. So when I'm talking sodium hydroxide takes one of these negative ions out of the hair. Calcium hydroxide removes 2. One is a fire, one's a worse fire, because the infrastructure has been compromised with the loss of the sulfur. The cross bond has been significantly weakened. Permanent waves don't do that. Ammonia converts cystine to cysteine. Ammonia takes the hard form of sulfur and converts it to the soft form. It doesn't take anything away. Then my oxygen gas, my neutralizer, takes the soft form and makes it hard again, giving me my permanent wave. So once again, the State Board doesn't go too much into too many details like that, but what they do want you to know is what side of the street you're on. Remember, alkalize, soften, and swell, State Board answer. Acids harden and shrink. But you, the technician, have to know which chemical altered the structure of the hair, and if there's damage, what that damage is. Because I can't use ammonia-based conditioners over sodium hydroxide relaxed hair. That's not the problem. They're fine, okay, for bleaches, okay, because the active ingredient in bleach is oxygen. So when my conditioner has ammonia in it, it just takes the hard form, converts it back to soft. That didn't happen with a relaxer. Remember, I had a fire, so now I need a reconstructor, and it should not have ammonia in it. So when I'm studying, and we will be studying shampoos, conditioners, styling gels, and what to use and what not to use on the hair that's been chemically altered, because that all has an effect on continuing damage. Now I can cook my food, okay, and if I have an electric stove and I turn the fire off, I still have heat for a significant amount of time. And in hair, we call that continuing oxidation. When the chemical has been rinsed from the hair, but the residue's left behind and the chemical actions keep going. We have to know how to take care of that so we don't have, quote, overprocessed hair, because we didn't understand that concept. So it's super important that you understand cuticle in its function, the cortex and its function, and the medulla and its purpose.